Hi guys, how are you doing? Nice to see you today. And today we go into the we'll go into the equation of the plane. Equation of the plane. So let's start. In 3D space. So we have XYZ coordinate system, a rectangular coordinate Cartesian system XYZ here, and we have a plane. A piece of plane here. This is a piece of plane. Equation of the plane define all the locus of the points which lie at the same plane. And the very common view of the equation of the plane is the following one: ax plus by plus cz plus d equal 0. So this is the equation of the plane which defines all points which belongs to the same plane here. I do not use this reading to frame my expression here. What about these numbers? Here x, y, z, they are coordinates, and a, b, c, d, they are some numbers. And all points with coordinates x, y, z, we turns in this expression into equality. They lie at the same plane here. At the same plane y, I want to shadow it by the reading this one plane here. But what about these numbers? A, B, C here, they are components of the vector n. I do not like n capital, which is perpendicular to the plane, the given plane. I want to use this green ink, so this n vector here, it is perpendicular to any two plane here. And d, it is the number, special number d is a number which can be defined through any known point which belongs to the plane. So how does it work? To define a plane, we have to know 3 points, because if we know 1 point, there are a lot of planes which go through this point, so infinite number of planes. If we just have 2 points, we have a lot of planes, because we can use these 2 points as an axis and rotate all planes around these 2 points, and we have an infinite number of planes. But 3 points, they define exactly the plane. There is only one plane which goes through 3 points. So let's consider an example here. For example, we have here we have 3 points P1 with components 1, 2, 3, P2 with components, for example, 0, 1, 1, and P3 with coordinates -1, 0, 2, 4, for example. And I want to define an equation equation all the plane which includes all the given points. Okay, so firstly I have to do the schematical URL situation. We have, for example, P1, P2 and P3, and we want to define the plane which includes, this is the plane which includes all of these 3 points. Okay, so we remember that we have here a canonical view or the equations of the plane plus d equals 0. Okay, and A, B, C, they are components of the vector which is perpendicular to this plane. It is perpendicular and vector. N has components and bar A, B, C. How can they calculate A, B, C vectors? P1, P2 vector, and we have vector P1, P3. So vector N is perpendicular to the vector P1, P2 because this vector is perpendicular to whole plane, and it means that it is perpendicular to any vector which belongs to the given plane. And this vector is perpendicular to the vector P1, P3. So the question, how can we find out the vector which is perpendicular, not equal, but perpendicular here to two given vectors? You remember that the ways to calculate this vector is to calculate cross product of two vectors, P1, P2 and P1, P3. And this cross product gives a vector which is perpendicular to both of them at the same time. It's very easy. So P1, P2 vector equal head point minus tail point, and it gives P2 we had before O minus 1, 1 minus 2 and Y1 minus 3, and it gives minus 1 minus 1 minus 2, and vector P1, P3 gives the same head minus tail, minus 1 minus 1, 0 minus 2, 4 minus 3, and it gives minus 2 minus 2, 1. Okay, so vector n, which is perpendicular to both of them, is a result of the cross product P1, P2 cross product P1, P3, and we have here I, J, K minus 1 minus 1, 2 minus 2 minus 2, 1, and we have I bar minus 2, 1 minus 2 times minus 2 plus J minus 1 times 1 minus minus j here, don't forget it, minus 2 times minus 2 plus k times minus 1 times minus 2 minus 1 times minus 2. And we have here I minus 1 plus 4 minus j minus 1 plus 4, and the last one gives, don't forget these bars because we have vectors here, 2 minus 2, 0. Yeah, and we have 3i minus 3j. So vector n has components 3 minus 3, 0. So this is the first one step here. We know now n vector. N vector is this one. So since that it gives us a, b, c numbers, a equal 3, b equal minus 3, and c equals 0. Now we just have to know d vector. So the first one here, the next one step here, we have to develop together the equation of this plane. It is 3x minus 3y plus 0z plus d equals 0. And it gives 3x minus 3y plus d, we can drop this 0 term here, plus d equal 0. After this we have to take any given point here. They can be 1, 2, 3 or 1, 1, and put into these formula. For example, we have take the p1, and it is p1 has components, coordinates 1, 2, 3. If you want to have a plane which includes this point, so it means that if we take these coordinates and put them into the given equations, the substitution turns the given equations into the equality. Since that we have 3 times 1 minus 3 times 2 plus d equals 0. 3 minus 6, it is 3 minus 6 plus d equals 0. 3 minus 6, it is minus 3, plus d equals 0. So consequently d equal 3. So finally this system of the equation of the plane is 3x minus 3y plus 3 equal 0. This is the final result of this work. So you have a homework. Check if the plane includes point 1 and point 2 and point 3. Point 2, for example, 1. Yes, includes. Yes. Okay. This is your home assignment here. Okay.